Hi everyone, Mrs. V here, and today we are going to be talking about polyprotic acids. Let's waste no time, get that PowerPoint on and start learning. As the name might suggest to you, polyprotic, lots of protons, might suggest a lot of hydrogen ions, and you would be right in your assumption. Let's have a look at some definitions. A monoprotic acid. Monoprotic, one proton. A monoprotic acid is able to produce one hydronium ion per acid molecule. Some examples of this are hydrochloric acid, nitric acid, hydrogen cyanide. Let's have a look at some ionization equations. First of all, for hydrochloric acid, HCl. Let's have a look. HCl. And we're having it reacting with water. And this is going to produce hydronium ions and chloride ions. And what we can see here is that one hydrochloric acid has produced one hydronium ion. So there's a 1-to-1 mole ratio between the hydronium ion and the acid. And that is always the case when you're looking at a monoprotic acid. You always get that 1-to-1 mole ratio between the hydronium ion and the acid. Now, I want you to pause the video and I want you to have a go at writing an ionization equation for nitric acid. We'll be back with the answer in a minute. Okay, nitric acid. All acids are aqueous. We're going to add water. Nitric acid is a strong acid, so we use the full arrow. If you want more information about strong and weak acids, you can check out my video on that topic. And we're going to get hydronium ions, and this time nitrate ions. And again, what we're going to see is that we have a 1-to-1 mole ratio between the nitric acid and the hydronium ion. So one nitric acid is producing one hydronium ion. Final example, have a go at HCN, hydrogen cyanide. How did you go with that one? HCN and water. This time, though, this is a weak acid, so this time we're going to use the equilibrium arrow. And still, what we're going to see is that 1-to-1 mole ratio. So that's the monoprotic acids. I bet you can't guess what a diprotic acid is. That's right, a diprotic acid can produce 2 hydronium ions per acid molecule. Examples for this one are sulfuric acid, carbonic acid, H2S, pretty much everything that has H2 in the acid formula. Now, the interesting thing about this is these acids ionize in 2 separate stages. Let's have a look. So if we look at sulfuric acid, in the first stage, the sulfuric acid will react with the water molecule. It's a strong acid, so we're going to use our full arrow there. And it's going to donate a proton. So what's going to be left is its conjugate base, HSO4-. And of course, we will get a hydronium ion. Now, because the hydrogen sulfate ion here, that's the hydrogen sulfate ion, because that still has a hydrogen that it can donate, then we can have another ionization step. So in this one, we have the hydrogen sulfate ion reacting with another water molecule. Now, the hydrogen sulfate ion is a weak acid, so we're going to use the equilibrium arrow. And we're going to get the conjugate base of the hydrogen sulfate ion. So we're going to lose a hydrogen, lose a positive charge, and we end up with the sulfate ion and another hydronium ion. So this is the sulfate ion. Now, what's happened overall then is that our sulfuric acid has reacted with 2 water molecules, and it's produced 2 hydronium ions and 1 sulfate ion. You might be wondering where the hydrogen sulfate ion went in all of this overall process, but if we have a look, the hydrogen sulfate ion that's produced here is being used up in the second step. So it doesn't actually end up in the products, although because it's a weak acid, there will be some hydrogen sulfate. But at this stage, we're just going to assume that this is happening to completion. It is your turn now. I would like you to pause the video and see if you can write ionizations for the 2-stage ionization of carbonic acid. We will be back with the answer. Okay, how did you go? We have carbonic acid, and that's going to react with 1 water molecule. Now, carbonic acid is a weak acid. It's what you actually get when carbon dioxide dissolves in rainwater. That's why rainwater is mildly acidic. And we're going to get the conjugate base of carbonic acid, which is the hydrogen carbonate ion. And of course, hydronium ions. Then that hydrogen carbonate ion is going to ionize further the hydrogen carbonate ion, also a weak acid, and we're going to get the carbonate ion and another hydronium ion. So if we're going to look at the overall process that's occurred, the carbonic acid has reacted with, there have been 2 water molecules, and that has produced 2 hydronium ions and 1 carbonate ion. And we see here that the mole ratio between the acid and the hydronium ion is 1:2. Did you get that one? Well done. Now, interestingly with diprotic acid, so we alluded to this earlier, that something like sulfuric acid might be a strong acid for its first ionization, but then the second stage doesn't go to completion. The second stage involves the ionization of the hydrogen sulfate ion, and that is a weak acid. So if we check in the table here, you'll remember we looked in strong and weak acids at the use of Ka values to determine the strength of an acid. So sulfuric acid is strong here, but the ionization constant for the second step is really quite small. So we would actually not in real practice get 2 hydronium ions out of this. We would get, per sulfuric acid molecule, we'd be more likely for 1 mole of sulfuric acid molecules to produce in between 1 and 2 moles of hydronium ions. And when it comes to triprotic acids, which of course have 3 ionization stages, then there will be 3 separate Ka values. This one, Ka1, will be for the first ionization, and then the second, and then the third. So let's look at those triprotic acids now. So a triprotic acid is able to produce 3 hydronium ions per acid molecule. And your example here is always phosphoric acid. And that is going to ionize in 3 stages. Now, I want you to have a go at writing those 3 ionizations. Remember, whatever is produced in the first ionization stage will be the starting ion for the second, and whatever's produced in the second will be the starting ion for the third. I'm going to come back with the answer. You just be careful to keep track of all your hydrogens and all your charges in this. This one can be quite confusing. Okay, how did you go with that one? Did you find that you were able to keep track of all those hydrogens and all those charges? Let's look at the solution. So we have H3PO4, and that's going to react with a water molecule. This is a weak acid, so we use the equilibrium arrow. Now we're going to produce the conjugate base of phosphoric acid, so that is going to be 1 less hydrogen and 1 lower in charge. So it'll be H2PO4, and instead of a charge of 0, it's going to be a charge of -1 now. And of course, we will produce a hydronium ion. Now we're going to take the dihydrogen phosphate ion that was the product of that reaction and ionize that again. This is a weak acid as well. So the conjugate base of the dihydrogen phosphate ion is the hydrogen phosphate ion. It goes down by a hydrogen and down by a charge. And in the final step, the hydrogen phosphate ion, HPO42-, reacts with a water molecule, and that produces the phosphate ion. So overall, what's happened, we started with phosphoric acid, there were 3 water molecules involved in this reaction. It has produced the phosphate ion and 3 hydronium ions. And if we look at the mole ratio, the all-important mole ratio between the original acid and the hydronium ion, we have a ratio of 1:3. I hope you enjoyed writing plenty of equations for your ionizations in the various ionization stages for monoprotic, diprotic, and triprotic acids. If you found the video useful, if you found that you are now a little more confident about writing those equations, then please consider giving this video a like. And as always, there is more fascinating chemistry to learn, so please subscribe to my channel. I am going to see you guys in the next video.